So welcome back to my YouTube channel. We are going to learn embedded system in 30 days. Here it's day 2 and we are going to learn the fundamentals of embedded system. Without any further delay, let's get a recap of day 1. So we learned about what's embedded system. We learned the definition and examples of embedded system and the difference between normal computer and an embedded system, its functions, and the architecture of embedded system. uh, we have defined what's the input microcontrollers and the output of an embedded system. We also compared the functions of microcontrollers versus microprocessors and the types of embedded systems. We got a brief explanation about microcontrollers and the block diagram of microcontrollers, industry relevant. So in day 2 it's going to be the fundamentals of embedded systems. We are going to learn about voltage, current, resistance, Ohm's law, and pull up and pull down resistors. So let's get a brief explanation about voltage. It's the electric pressure which pushes the current flow, which is denoted by V. The units of voltage are volts. Example: Arduino operates on 5 volts and ESP32 operates at 3.3 volts. Current current is the flow of electrons in a conducting material or a medium. It is denoted by I and units are amperes. LED requires current to glow, which is measured in amperes. Resistance, it's the force that opposes the flow of electrons or flow of current in a conductor, which is represented by R, and the unit are ohms, which is represented with the symbol. Generally, resistance is used for protecting the components from burning out. We also know that Ohm's law, which is defined as V equals to IR. Let's get an example. When the voltage is 5 volts and LED current is 20 milliamps, the resistance would be 250 amps, which is done using R equals to V by I. It's a simple algebraic expression. So let's compare about analog and digital signals. Analog signals are continuous values which are found in temperature sensors, any sensor which works continuously, and digital signals are only the signals which are accumulated in zeros and ones. It's generally switch or a button. This is the main part of this video: pull up and pull down resistors. When button is directly given to microcontrollers for work, it generates random values, zeros or ones. It might be unstable and produce noise. This condition is known as floating pin. Floating pin has some characteristics like no fixed voltage, picks random electromagnetic noise from the circuit, and causes unpredictable behavior. To avoid this, we use pull resistors. It generally helps the pin to stay at known logic level even the button is not pressed. These are divided into pull up and pull down resistors. So this is pull down resistor. It has switch, it is connected to microcontroller and a relay button. It's only the example. So in general case, when the switch is on, the power is transferred through the microcontrollers and given to the relay. If in this condition the relay provides the output for the further circuit, but when the switch gets off, the other circuit provides unnecessary noise due to electromagnetic waves, which might also affect the microcontrollers and causes malfunction in the relay button. So we use resistor and we connect it to ground. When the switch is on, it functions normally, but when the switch is off, if any external electromagnetic signals or waves try to transmit through microcontrollers, these pass through the resistor and gets to ground. So this is pull up transistor where the voltage is given to the resistor. So voltage is given to the resistor and directly connected to microcontroller and to the further circuit, but here we add an interrupt using another switch which is directly connected to ground. These also have the same function as pull down transistor, but it works differently. When voltage is given to this resistor, it directly transferred to the microcontroller, but it's directly transferred to the microcontroller when the switch is on state. When the switch is off, the voltage directly transfers from resistor to ground, which avoids unnecessary noise. So let's assume if we don't use the resistor case, button is directly connected to the microprocessor. What are the consequences? The consequences we are going to face are the circuit may be destroyed. It causes short circuit and huge current flow and hardware damages. This is the main condition where there might be a question. So we are at the end of the video, so these are the tasks you need to complete. Have a look. These are the contents which we are going to learn for day 3. ATmega 328 architecture, memory types, register concept, GPIO, internal working and clock system basis. We are going to use Arduino IDE and Proteus softwares for designing and writing codes using C and implementing it on Proteus. So let's meet tomorrow.